Hey guys, Dexter here from Dexter's Workshop. So I finally took the time to breadboard quite an old project that I was working on. And because uh, I have a little son of 2 months, you might hear some strange noises because I had to relocate part of my shop at home. So if you're hearing strange noises, is either my son, my cat, or my wife, depending. So here we go. I will present you a little bit the project. It will be a video that it will be longer than the average ones. Uh, the idea behind it is to motorize the potentiometers in any given amp. Basically, I wanted to develop a system that could be fitted on virtually any existing amp, because if you're going to design an amp from scratch, you can actually design it with motorized potentiometers, all of them or some of them, but the idea was to fit the system on existing amplifiers. The idea behind it was more of a studio use or live performance, but generally speaking, a studio use, because if you have a band that is going to record in the morning and another band at afternoon and another band in the evening, you can actually save presets for the bands, and it will save a lot of time to set up the amplifiers with different settings. Basically, what I'm having here, it's a very crude prototype that is taking MIDI, CCs and PCs, and via a stepper motor it's actuating a potentiometer. What I don't have at the moment, because the end of the travel sensors did not arrive, so it will have an end of travel sensor here that will read the end of travel, and that would be the 0, and driver, the microcontroller board and the MIDI board. The speed, it's quite nice, the response is quite nice, but I would let you see it. So at the moment I'm sending CC messages with values from Reaper. I'm going to press play and see how it goes. So basically there are no steps lost in the process. I've left it to run for a couple of hours. As you can see, it tracks the messages very well. Now, if I'm going to press stop, the motor should return home, and let's see if it will. So it's just lining itself. A way to do this, a way to actually detect the end of travel, it's either by back EMF or by sensors. But you cannot use back EMF detection or stall detection in this particular case, because the rotation force is different for different potentiometers, so you cannot calibrate it for each potentiometer. So yeah, that's my son. Started to cry for no particular reasons. So you can't actually use the back EMF for FFT stall detection in this case. I know it's a little bit boring, but I will uh, keep all the details to a minimum. The challenge was not necessarily the whole actuation problem, because that's kind of easy. You have a stepper, you have a elastic couple, and you have a potentiometer. That's it. That's all. The problem is how you're going to integrate this without much of a hassle and to be put on basically on any existing amp, or I'd like to say 90% of the amplifier of the existing amplifier. So this particular mechanical fixture is subject to a small patent and will be presented after the papers are going to come out. Just the mechanical system, nothing else, because the other stuff you can't patent it in any way. Basically, what I can do here is I'm going to show you this. So this was the CC. As you can see, the speed is decent, at least, and I will also tell you why it was a challenge in the first place after that. So this is basically the CC. We are going to to call it home. Okay, so what we are going to do now is I'm going to send also PC messages, so I can send between 0 and 127, so I go 127, and I'm going to press send now, and this particular message will send the potentiometer to the end of the travel. If I'm going to set it 0 here, it should align itself with the mark on the enclosure. So we are back, let's say a value of 60, send now. Okay, the challenge behind it is the same challenge that you encounter in the CNC system. It's the acceleration and the speed of the motor. Because if you are going to use a certain speed and you are going to use a high acceleration, you might find out that you're going to stall the motor. This particular motor is a very small stepper. It's 0.8 amps per phase, and it's one of the most the smallest, if I remember well, the smallest NEMA motor on the market. So this one here, it's very small. It's 28 millimeter by 20 by 20, so it's very small. So the challenge was to implement acceleration and speed strategy that can be modified to suit any particular potentiometer or system, because some would move easier, some would move harder, some would need a different torque to rotate them. So that was one of the challenges that I had to solve. And another challenge was the mechanical fixture that I was talking about, and I had to burn my brains out to put it in to solve that particular problem. So at this particular moment, this is the prototype that I have. Also, just to show you, so at this particular moment we are reading 1.7 ohms on the potentiometer, and if we are going to issue 127. Let's see. So it's 230, 240 was the maximum value for this particular potentiometer. It's alpha pot, and usually 250K would vary between 230 and 250. Uh, I didn't actually find some 250 spot on values. So if I'm going to, I don't know, put it to 60, keep in mind that it's a logarithmic pot. So we have 36K, and we're going to send value of 10. Yeah. Another thing that needs to be kept in mind is that MIDI messages, any type of MIDI messages, CC values and PC numbers are actually between 0 and 127. So between 0 and 127 you would have to extrapolate 128 values on a rotation angle of 300 degrees plus minus 5 degrees. So basically you will get 128 steps on the potentiometer, because that's MIDI value limitation. It's not something that you can overcome. I hope you will find this interesting. So I will keep you posted with the evolution of the project. At this particular moment, I'm quite happy, and I do think that it will turn out quite excellent, as all the necessary blocks were already designed and everything is working as it should. So thank you for watching, guys. Again, I hope you find it interesting and entertaining, and see you later. This is Dexter from Dexter's Workshop. Bye, guys. Have a nice night.